We are now going to look at differentiating trigonometric functions, and specifically how we're going to apply the different differentiation rules to this trigonometric functions. But let's first look at the chain rule applied to these trig functions. First, we look at the chain rule. Okay, now if you differentiate a function f, but in the function itself there's another function, what you do is you differentiate the big function and then you multiply it with the smaller function's derivative. Now this is difficult to imagine, so let's do a couple of practical examples. First example will be, let's look at fx sine 5x. First of all, you'll see there's the function is sine. It's a sine function, but in the sine function there's another function which is called 5x. So what you will do when you get the derivative, you'll differentiate sine 5x, the big function, the sine first. Now you'll get this differentiation table where it indicates what will happen if you differentiate sine and what will happen if you differentiate cos. But in this case, just know that if when you differentiate sin, then you get cos. So you get cos 5x, but then we still have the function in the inside, and then you must multiply it with that one's derivative, and that's just 5. Because 5x, if you differentiate that, it's just 5. So again, yeah, you differentiate the big function and then you multiply it with the smaller function inside the fx. That one's derivative, you multiply it with that, and this is what happened there. So the answer is just 5 cos 5x. But let's look at another example, and this time the function looks like this. This is dy cos 2x squared, and now again see that they say the function is y equal to cos 2x squared. So when we differentiate, we won't use f accent x, we won't use that, but we'll use dy, differentiate y in terms of x, and again you have the big function which is cos. So if you differentiate cos, you'll get sine, you'll see that in your table, and then you multiply with the smaller function's derivative, which is then 2 times 2 is 4, 4x, and you subtract the 1 from the exponent, and it's just then 2 minus 1 is just 1 plus 1. Okay, so we can write it as 4x sine 2x squared. Okay, now let's look at a third example. Let me take green. Third example, let's say you have d dx. You see this notation. So again, just a different notation, also to get you used to different types of derivative notation. Okay, then how will we calculate this one? Okay, so again you differentiate the big function, the tan, and the tan differentiated is sec squared, and you keep that smaller function in there, and then you multiply this with the differentiated function inside the tan. So it's, if you differentiate this, it's 3 times 2, it's 6x squared, and there it's just minus, well, the 1 goes to the front, and subtract 1 from the exponent, so it will just be minus 1 x to the power of 0. So if you rewrite that, it would be sec squared 2x3 minus x, and this was, we should rather write this in a bracket just to say that, well, it's the whole thing we multiply with a sec squared. Okay, but anyway, that is 6x squared minus 1, and you can actually leave it like that, that's fine. Let's do another example, maybe use a white this time. Okay, so Now again another notation, you differentiate in terms of x, this cot 1 minus 9x. If you differentiate cot, it becomes it's negative cosec squared x. It becomes cosec squared x. That's how it is. And you keep the 1 minus 9x, but then you multiply it with this one's derivative. And again, if you differentiate a 1 or a constant, it becomes 0. So that will fall away. Then if you differentiate this, the exponent 1 goes to the front, so it's negative 9 times 1 is just negative 9. X to the power of 0 you're left with, so you'll have negative, so the 1 goes to the front times the 9, and you subtract 1 from the exponent, and then what you have left is 1 over 9x, and it's negative 9. Negative 9, you can put it at the front, so it's negative 9 times the negative 1. If you don't see a 1 there, it's a 1. It's just then 9, because negative times a negative is a positive. Cosec squared x, 1 minus 9x. Okay, just close the bracket there. Then let's look at another example. Okay, so let's look at 5 fx equal to sec 10x. Okay, if you differentiate sec, it becomes, this is now you must just be aware, it's sec 10x. You keep the sec 10x, but it also is tan 10x. Okay, so it's both of them, but then you must multiply with a 10x derived, and that is 10x. If you differentiate 10x, you are just left with 10. So the answer is 10. Again, yeah, just check the notation. The fx was the function, so if we start working out the derivative, it becomes 4 accent x. Okay, so the total answer, the final answer is sec 10 sec 10x times tan 10x, and you'll see this derivatives in your table. If you differentiate sec, it becomes sec tan. Okay, then let's look at another example. 6. Let's try another color. Let's do a yellow again. Okay, so y. Now it's arc at tan 5x. If you differentiate this one, let's move it a bit down. Arc tan 5x. Well, if you differentiate arc tan, you'll get 1 over 1 plus, and that whole thing must go into this space there. There's usually an x there. If it was arc tan x, it'd just be 1 over 1 plus x squared, but now it's 5x squared. Okay, but then you must still multiply with this one's derivative, and 5x derived is just 5. Okay, so then it's 5 times the 1 there, so it's 5 over 1 plus, and this one squared is 5 squared is 25 x squared. Okay, and let's try a last example. I'm going to have to write a bit smaller because my space has run out. ddx, and again, yeah, sorry, when you derive, you say dy dx because your function is called y, so you differentiate y in terms of x. Okay, then arc, let's do arc sine 1 minus 2x. Okay, if you differentiate that, again, when you start differentiating, this notation will just fall away. So arc sine is 1 over square root 1 minus, now there will usually be x squared if there was an x there, but now it's 1 minus 2x, it'll just say 1 minus 2x squared, like that. Okay, then you times it with that one differentiated, and to differentiate that, well, the 1 is a constant, so that will fall away, and you will be left with negative 2 as a, if you differentiate that. So the final answer will be negative 2 over 1 minus 2x squared.